All right. I will do problems 1 and 2 with you. And then if you want to do any more problems, just let me know. I'd be happy to help. So this is April 4th. Do any of you guys know the significance of the date, April 4th? Well, your job is to figure that out sometime today. Something in history happened in this great country on April 4th, and your job is to figure out what it was. Hmm? Nope, that was in December. U2 wrote a song about it called Pride in the Name of Love. Anyhow, I'll let you figure that out. So this is assignment number 26. Let's do problem 1. So I'll copy it onto the board just because if anyone is watching this, then maybe this will help them to see the problem. So what did we learn yesterday? Right, the quadratic formula. So before we can use the quadratic formula, what do we have to figure out? Good man. So what is A in this problem? It is. What is B in this problem? Nice work, Zane. And what is C? Nice work again. Good job. All right, so let's get into it. And the quadratic formula, you'll remember from yesterday's lecture, I'll put it up here in the corner, is the opposite of B plus or minus the square root of B squared minus 4 times A times C, and then all of that gets divided by 2 times A. So that's in your notes from yesterday. So now that we know who A, B, and C are, we should just be able to plug those little boogers in and see where the morning takes us. So what are we going to put first? Negative B. Yeah, and we can write, you're right. I mean, the variable in this problem is B equals. So I'm just not going to write that. Instead, I'm just going to start using, I don't want to confuse the B with the B. I probably should have proofed this and taken out any problems that had B, B as a variable, because that could get confusing for us. So no, let's not worry about that. Change it to X if you want. I don't care. So what are we going to, when we use our formula, what are we going to put first? We would not. Right. And you remember yesterday in the notes that I did where I did put the 0, but then I quickly took it out afterwards because the formula starts by saying to do the opposite of B. And if B is 0, the opposite of 0 is 0. So I choose not to put that. So instead, I'm just going to start right away with the plus or minus part. And I'm going in. And what would be the next thing that we would do? Nice job. And again, we encounter that 0 again where he doesn't need to be, because 0 squared is like, what's the point, right? So we'll just bypass that. And like Zane said, we'll just start right at the -4 times blank. And then we divide all of that by, what is 2 times A? Good job. So now it's time to go and backfill our A and C values. What are we going to put in those blanks? So I'm going to put in a 2 for my A and a -16 for my C. I'm just popping those suckers right up in there where those arrows are pointing. Nothing to it. Now we got to do some math. And I think I said this yesterday, the majority of errors will occur, unfortunately, on just this rinky-dink multiplication. So use a calculator. But as the numbers get bigger, there's no shame in using a calculator. But the one thing I know for sure is when I see those 3 numbers multiplying inside the root sign, they are 2 negatives and 1 positive, which means that they will definitely come out to a positive. Yeah. So what is 4 times 2? Yeah, just 8. And then 8 times 16. Good. So where we currently sit with our quadratic formula is we have, I'm going to come work over here for a minute. We have positive negative root 128 divided by 4. Going to pause this real quick. What do we do after this? Right. And 128 is not a rootable number, but it is definitely a breakdownable number. So this is the part where we kind of go off to the side and we take our square root of 128 and we build one of those little root trees. What two numbers are the best pair possible that make 128? That would work. But the trouble with these, I'm going to write these in and then I'm quickly going to undo this, is while 16 is a good choice, I know it's not the best choice because 8 would have to go. So let's not settle for 16 and 8. Let's go bigger. Go deeper into your list of numbers that are square rootable. In our notes, we called it the red list. There's a really big number that has a square root that can go into 128. Again, it would work, but the trouble is that if I do 4 and 32, then I'm leaving myself in a position where this root over here still has a lot of work left to do. So we haven't found it yet. You guys have found two sets of numbers that do work, but I'm not going to take either of them because I want the one that's not going to make me do it in 2 steps. There's a really big number that goes into 128 that we should love. Yeah, we already tried 16 and 8. That one. 64 and 2. And we love that because when we look at the leftover root, the 2, then we know that it can't go any further. So its simplified version of itself is 8 root 2. So what it's time to do now is take this 8 root 2 and re-inject it into our answer in place of where it used to say root 128. And so my current answer, not done yet, is positive negative 8 root 2 over 4. And then what's my final step? Simplify, right? And remember that this 2 that I'm pointing to with an arrow is off limits. He does not get to play anymore. He's a dead root. He'll just stick around. But what we are going to do is reduce these numbers that are not rooted. They're just regular old numbers. And 8 and 4 reduce down to what? 2 and 1, but I'm not going to put the 1 on the bottom. So if you think of this 8 becoming a 2 and this 4 becoming a 1, the clean, proper version of the answer is just positive negative 2 root 2. Done. Our next answer will look different from this because our b is not going to be a 0. But whenever b is a 0, like that problem and then problem number 7, you're going to get these strange feeling kind of answers. So get used to that. Any questions on number 1? When you, at some point, start seeing my answer keys, as the computer generates my answer keys, it generates the answers like this. It'll say 2 root 2, comma, negative 2 root 2. That, of course, means the exact same thing. It's just how the computer communicates positive and negative answers. We, math people, like to package it up concisely. The computer just writes them out separately. So understand that it's the same. Okay. All right, let's head on to problem 2. So problem 2, we have 4x squared minus 6x plus 1 equals 0. So once again, we're not going anywhere until we acknowledge and write down our 3 values. What is A? What is B? Yeah. And what is C? 1. As I said yesterday, you really should write those down. It takes I don't know, 6 or 7 or 8 seconds, and it's totally worth it. I found that for some reason it really makes a difference. I'm not going to grade you up or down. I'm just telling you, you're probably going to do better if you write down A, B, and C. So let's begin. X equals, what is the first thing we write? The opposite of B is 6, right? Remember, the first thing you always do is take the negative or the opposite of B. And since B is already a negative, we write positive 6. And then before we do any more math, we write plus or minus, and then we put a square root sign, and we make sure that it's long enough that we probably think it's too long. I find often that I run out of space under my root sign. No harm in making it a little extra lengthy. What goes first? Someone other than Zane, no offense, Zane, but Zane's answering all my questions. I'd love to hear from Kyla or Skylar or Levi or Mari. Heard from Brenna. What goes first inside the square root sign? B squared, right. And since B is negative 6, when you square it, it's going to become positive 36, right? If you type this into your calculator is going to say negative 36 because your calculator is just a stupid piece of circuitry and plastic. So you know that negative 6 properly squared is positive 36, right? So the reason your calculator lies to you like that is because you typed it in wrong, because all it does is what it's supposed to do. It does 6 squared. So if you ever find yourself needing to use a calculator for this step, which you will when B gets bigger, just don't even put the negative in at all, because you know it's going to come out positive. What's the point? So I'm right here just going to put 36. Nice. And then after that, I don't really do any math for a few seconds. I just write minus 4, and then I put 2 blank sets of parentheses. And Levi, what goes on bottom? Skylar? Good job. Levi, the bottom of the quadratic formula, I know you copied it down already, but I'm going to bring it up here one more time. The quadratic formula says this, and it will never change until humans cease to exist. We'll just keep doing it this way. The bottom is always take whatever A is times 2. Got it? Okay. Formulas aren't really up for debate and like comprehension. Formulas at this stage in the game for us are just take it, plug stuff in. So thank you, Skylar. Good job. The bottom is definitely 8. And then I'm going to go and I'm going to backfill my A and my C values. In place of A, I'm going to put 4. And in place of C, I'm going to put 1. Okay, and this goes back to Kyla's question. Your line of questioning inspired me to do a better job. So thank you throughout the day. That this is not one where the minus sign is going to switch to plus, right? We talked about this again per Kyla's insistence, which again, I really appreciate, that sometimes the minus switches to plus and sometimes it doesn't, right? It's just not, it doesn't always happen. You just follow the laws of math. So in a case like this, I really think of what's going on. I'm going to just write it in red, just right up above the square root sign for you. I really see this as just 36 minus 16. Because 4 times 4 is 16. 16 times 1 is 16. Everybody comfortable with that? So when I write my next line, I'm going to have 6 plus or minus the square root of 20. And it's always at this point, just get used to it, where you have a decision to make. You're at a crossroads. Do you put a box around this and say, there it is, I'm done? Or do you go further? In this case, we go further. Why is that? Like, how do we know? Because 20 can be broken down in a meaningful way. Like 30 could be broken down a ton of ways, but none of them are meaningful. But 20, who do we think of when we think of 20? 4 and 5, right? 2 and 10 are trash, but 4 and 5 are lovely because If you bust down into two roots and put 4 or 5, what's the square root of 4? So 2 root 5. So yet again, get used to this. This just is like anything else in your life. You practice and you just form a routine. You get good at this. This 2 root 5 is going to go now and replace this root of 20. So my next line of my answer says to do 6 plus or minus 2 roots of 5 over 8. How about now? Do the triangle thing, the Dorito thing, call it whatever you'd like. But there exists now this triangle of numbers that can/need to be simultaneously reduced. What can 6, 2, and 8 all be divided by? 2. So what happens is we wind up creating 3 different numbers, only 2 of which are going to be acknowledged, because the 6 becomes a 3, the 2 becomes a 1, and the 8 becomes a 4. But we would agree that that 1 is an example of one of those that we just don't need. Like, who really says like 1 times something? What's the point? So when we express our final answer cleanly, we're going to say x equals 3 plus or minus a square root of 5 divided by 4. Nice and clean. Would you like to do a few more together? It's totally up to you. We can do a couple more. Let's do number 3. And then I'd for sure like to get to number 4. And then I'll probably, even if there's time, I'll probably quit talking, just because at that point it'd be good for you to maybe do a couple by yourself. Quadratic formula is pretty tricky at first, and then you start to figure out, like I said, the routine of it, and it just becomes like kind of second nature to you. So in problem number 3, instead of me copying it down, guys, what's our A value?
3.
Problem number 3. A is 4. What's B?
-6.
Good. And what is C?
-6.
Okay. So it's time to hop into the formula. Let's do this. What's the first thing I'm going to write in my quadratic formula? Good job. There you go. The opposite of -6 is 6 plus or minus an awkwardly long square root sign. And what's going to go first inside there? Again? Yeah, just like the last problem, B is yet again -6. And we know that that squared is positive. And as far as habits are concerned, I've made it very clear. This is one of mine. I just write -4 blank blank, and then I head to the bottom, clean that up, and then come back. What is 2 times 4 on the bottom?
8.
Hey, these are very similar problems. I probably should have noticed that. What's going to go in my 2 parentheses?
4.
Nice. So is this going to be one of these problems where the minus stays subtraction, or is it going to flip up to plus? It's going to flip to plus. And the reason why is because this minus that I'm pointing to and this negative that I'm pointing to, they're going to find each other eventually. So my take is, as we have this next part of our conversation, let's not think of the negatives. Let's just say the numbers and put them in our calculators as regular 4 times 4 is 16, and 16 times 13 is 208. And so when I see what's inside of the square root sign, I really see it now as 36 plus 208. Are we okay? All right, so now I'm ready to hop to my next line, which is going to say 6 plus or minus the square root of, what is the answer to that? 244. And here we are for the third time at the crossroads where we say, are we done? No. So we got to go now and play around. And thankfully, there's 8 of us working as a team, where we can take this square root of 244. And between the 8 of us, we can probably find the best way to break him down. Yeah, and actually, that's the only way to break him down. Good find. 4 times 61 is actually the only way, other than using a 2, which would be pointless. So great find. So that becomes 2 root 61, which again is going to replace the old ghetto root 244. And my answer now looks like this: 6 plus or minus 2 roots of 61, all divided by 2. This time when we draw our triangle Dorito thing, what can they all be divided by? 2. And honestly, I don't know where I got a 2 from on the bottom. Yeah, of course it's 8. I don't know why. I even have 8 right here, and then I just switched it to a 2. I don't know. I do weird things. But my answer is still the same, right? The numbers can all still be divided by 2. So apologies for the confusion. So the 6 is going to reduce to a 3. The 2 is going to reduce to a pointless 1. And the 8 is going to reduce to a 4. Leaving our final answer as n equals, how would I write this? That's it. Just feeling good? All right, let's take a gander at problem 4. Hey, Levi, would you mind pulling the door shut for me, bro? Thanks, I appreciate it. Just put the blocker in though, but let's get block the noise out. So in problem number 4, what is my A value? What's my B value? And what is my C value? Nice. Right. And for the 4th time now today, we're ready to plug things into our quadratic formula, which you're probably reaching a point now where you're starting to feel like you haven't memorized. I think I said this yesterday, that it's inevitable. Eventually you memorize it, and it doesn't really happen on purpose. It just happens. So what's the first thing that I will write? 5 plus or minus an uncomfortably long square root sign, in which I will first put what? 25. Always a positive number right there. Okay. Again, your calculator will try to trick you, but it's not its fault. It's that we humans forget our parentheses and do really stupid things. And then I'm going to put minus 4 blank blank all over 2 times a, which is 6. And then I'm going to go back fill my parentheses with a 3 and a very large negative 68. So again, the question is always, is it a stay minus or switch to plus? This is a switcher because the minus has a negative somewhere on down the line after him. And so using your calculator for this one, you definitely want to use your calculator for 4 times 3 times 68. Oof, what is that? So we get 25 plus 816. It's a good thing we're working as a team here. These are some big numbers, but we're tough. We can handle this. So we're now looking at 5 plus or minus the square root of 841. Oof. Divided by 6. This is a really good time to know how to use your calculator to do square roots, because if you know where the square root button is on your calculator, one of the smartest things you can do when you get a big number like this is just right out of the gate, just say, maybe it's square rootable. You know what I mean? Like maybe if I just type into my calculator the square root of 841, maybe it'll just give me a whole number and I won't have to worry about this whole stupid make a tree thing. Do you guys know what the square root of 841 is? It is. It's 29. I don't even need a tree. That's awesome. So I'm going to replace my square root of 841 with just a regular number. And does anyone remember from yesterday's? I taught a lot of stuff yesterday. It's hard to remember everything, but do you remember what we do with answers like these? Yeah, we actually, in a case like this, the expectation, math people, I know sometimes it seems like we're inconsistent, but with rational answers like this, we actually want you to tell us now what both answers individually are. We don't really give a rip with irrational answers, but with rational ones, I want like substantive, like meaningful numbers. So having said that, the first thing that I do as your teacher is I circle the plus sign and ask of you that you track that pathway and then divide by 6. What is 5 plus 29? 34. And if I take 34 and put it over 6, that's actually one of my answers. So one of my answers I can say is x equals 17 thirds. That's just me reducing that fraction. The other answer, I'll circle in yellow the minus pathway. So this time you reset, go back to the beginning, and you trace the other pathway. So what is 5 minus 29? It's not 24. It's negative 24. And if I take negative 24 and divide it by 6, what do I get? So my other answer is negative 4. I like to throw problems like this in every once in a while just to keep us on our toes. Because not always when you use the quadratic formula will you get answers that have roots in them. You saw this in one of our examples yesterday, that sometimes you get answers like this, which going back means that you could have actually factored this, but that's not what we're practicing right now. So you guys feel like you got this? Okay. So I've done 40% of the work with you. I'm going to let you do some by yourself now. There will be one more. Yes. Mm-hmm. I'll pause the recording and just keep it active so that if you have any questions that are like, ooh, everyone should know this, then I'll unpause it and add it in. But I'll pause it for now.